All righty, our final unit on section on limits here. So we've already talked about limits approaching infinity and negative infinity, but we're gonna just do a little bit more with it here, just so we kind of get the gist of it here. So 3 from the negative side, that's the left side. So notice the graph here goes all the way down. So that would be going to negative infinity. However, we would say, although it goes to the negative infinity, we'd say that the limit does not exist. And the reason why it doesn't exist is because it is unbounded. And likewise, if we come from the positive side here, we see that our graph up here goes up to positive infinity. And when it goes to positive infinity, again, we would follow that up and say, well, okay, well, it's unbounded, so that the limit doesn't exist. When it goes to negative infinity or positive infinity, the limit does not exist. So how do these limits relate to the graphs? Well, notice these limits, they approach infinity, or they go to positive or negative infinity at asymptotes. So when a limit does go to a positive or negative infinity, that would be an asymptote. So let's write that down. So when the limit at some number, and again, I don't really care if it's from the left side or the right side. I don't care what the number is either. When it approaches plus or minus infinity, we'd say that x equals that number. So whatever that number is, x equals that is the vertical asymptote to the function. So limits go to infinity, those are related to vertical asymptotes. What about if x was going to infinity? So for instance, when x is going to negative infinity, notice what's going on in our graph here. When x is going to negative infinity, our graph is going to some number. If it doesn't go to some number, we don't worry about it. But if it does go to some number, then that ends up being a horizontal asymptote. So when the limit as x approaches plus or minus infinity, and we'll just call that a number. It doesn't matter what number. If it approaches a number, so it doesn't approach infinity or negative infinity, it actually approaches a regular number, then we say, then that number is the horizontal asymptote. So it turns out asymptotes are related to infinite limits. So limits approaching infinity or x approaches infinity. And those are actually the formal definitions of asymptotes. There are actually more limits. So we have vertical asymptotes. They exist when you're at the x value that makes your graph go to infinity, horizontal asymptotes exist at the y value your limit goes to as x approaches infinity. So what we're going to do here today, friends, we're just going to play briefly with this a little bit. We're not going to go too terribly crazy. We're going to go play just a little bit with it here. So first thing, vertical asymptotes, and this is our definition here. Again, we've kind of already seen this. If the graph goes to infinity, then x equals c would have been your vertical asymptote. When x approaches negative or positive infinity and your limit goes to some number, then that y equals L would be your horizontal asymptote. And then part of the thing you need to remember here also, friends, is when we divide any number by infinity, that's always going to be equal to 0. If we divide by positive or negative infinity, it equals 0. Okay? So first up, let's go ahead and determine how to figure out the limit as x approaches infinity. Well, let's not overthink it. Okay. So I'm going to just divide everything by x squared. And when I do that, friends, I end up with 1 minus 3 over x minus 5 over x squared. So that's 1. 3 divided by infinity is 0. 5 divided by infinity is 0. So the whole limit is equal to 1. Now, what if we look at this in terms of like a function? What's the horizontal asymptote? Well, remember back when we were dealing with first semester, when we were dealing with rational functions, we had our rules for asymptotes. Well, those rules still apply. They didn't change at all. And we could still use them here. Notice they have the same degree. They both have the same degree. Therefore, since they have the same degree, the horizontal asymptote is the leading coefficient divided by the leading coefficient. Well, the leading coefficients are 1 and 1. So the horizontal asymptote is y is 1 over 1, or y equals 1, which is the same thing we found out when we did the limit as x approaches infinity. Again, horizontal asymptotes exist when x approaches positive or negative infinity. Vertical asymptotes exist at an x value if the limit goes to positive or negative infinity. Infinite limits, or limits approaching infinity, or limits when x approaches infinity, those are always related to our vertical and horizontal asymptotes. All right, so let's see if we can't graph these. Now, for instance, we're looking at this graph right here, and we want to know what this limit looks like. So we could graph it to figure it out. But one way to think of it here is I know that at this asymptote, it's either going to go to positive or negative infinity. The nice thing is to try to figure out what kind of infinity it is. So one way to do it is just look at the number, 3 from the positive side. So that'd be like 3.001, something just a little bit bigger. And when you do that, notice 3 minus 3.001, that would end up being a very positive small number. So we have a positive small number that's in our denominator. So we have a positive 1 divided by 0, or honestly, it's a positive small number. So 1 divided by a positive small number would be a positive infinity. However, since it is infinity, we always have to follow up with the limit does not exist. All right, friends, why don't you guys go ahead and pause this next one and see what you guys can do with. Go for it. All right, so from the negative side here, negative 2 from the negative side, that'd be like negative 2.001, something like that. And if we're going to add that to 2, that means I'm going to end up with a small number. So if I plug my negative 2 up top here, 3 times negative 2 is negative 6. I end up with negative 4 over 0, but that 0 is more like a negative small number. So negative divided by negative would make this a positive infinity again. So sometimes it helps to think of it when you're looking at an infinity to try to figure out if it's positive or negative infinity. Try to think of it as a number that's really relatively a small or relatively big. And again, since it goes to infinity, I got to add on that it does not exist. Well, sometimes, friends, it just honestly helps to go ahead and just graph it. So think about tangent and go ahead and graph this function. And let's see what you guys end up getting for this limit. All right, let's see how you did. If I'm dealing with tangent, I have a horizontal asymptote at pi over, I'm sorry, a vertical asymptote of pi over 2 and negative pi over 2. And it comes down and it goes up. So if I'm approaching negative pi over 2 from the positive side, that would be this part right here. And I'm going to negative infinity. So that means this graph right here equals negative infinity. But that also means that the limit does not exist. All right, now, when we're dealing with x at infinity, one of the best things to do to figure out how to evaluate these is always to divide by the x with the largest exponent, the largest degree x in your denominator. So in this case, I only have a single x. So I'm going to divide everything by x to the first. Every term in this limit, I'm going to divide by x to the first. I mean, I could still treat it as a function and say, well, they have the same degree, so it's going to be 1x over 3x, so 1/3. But if we're going to deal with it like limits, I'm going to divide by the largest x with the exponent in the denominator. And when I do that, I end up with 1 plus 5 over x over 3 minus 1 over x. And anytime we still have an x, and we're dividing by infinity, that is going to be equal to 0. So 1 plus 0 over 3 minus 0, that would be equal to 1/3. All right, friends, why don't you guys go ahead and try this here and see what you guys can deal with and do these last couple. Go for it. Okay, let's see how you did. First up, this is my biggest x, my exponent, so I'm going to divide everything by x squared. So everything is going to be divided by x squared. So 5 over x squared minus 1 over x squared and then x squared over x squared minus 3 over x squared minus 4 over x squared. And when I clean that up a little bit, I end up with 5 over x minus 1 over x squared all over 1 minus 3 over x minus 4 over x squared. So that would be 0. Anytime we divide by infinity, it's 0. So 0 minus 0 over 1 minus 0 minus 0. So that's 0 over 1, which is 0. And friends, think about it in terms of our horizontal asymptotes again. The denominator, the degree in the denominator is bigger than the numerator. Well, the horizontal asymptote would always be y equals 0. All right, one more to try, and then we will call it a unit. So here we go. The biggest one in the denominator is an x squared. So we're going to divide everything by x squared. So if we divide everything by x squared, I get 7 over x squared minus 3x squared over x squared all over 8x squared over x squared plus 6x over x squared minus 1 over x squared. Which ends up being, friends, then 7 over x squared minus 3 all over 8 plus 6 over x minus 1 over x squared. And again, anytime we're dividing by infinity, it equals 0. So I have 0 minus 3 over 8 plus 0 plus 0. One of the things I kind of like about this, friends, is it really does kind of clarify and give reason behind why that our little pattern of the y-intercepts, why all they work. When you were, not y-intercepts, I'm sorry, horizontal asymptotes. Back in the beginning of the year when we were doing horizontal asymptotes, this really does help provide the reasoning, the meaning, the understanding behind why it all works. But we've reached that point. That's about all we got for today, friends. We're just doing a real quick thing on vertical asymptotes and horizontal asymptotes. So remember, vertical asymptotes. When x goes to infinity, you have a vertical asymptote at x equals c. If x approaches infinity and it goes to a number, then you have a horizontal asymptote at whatever that number is. Remember that, friends, and you will be set. So it's been a good year, folks. Look forward to seeing you in class, and we'll clean this whole thing up. Talk to you guys later. Take care.